Have you ever stopped to wonder why the sky is blue? It's a question as old as humanity itself, and today we're going to dive into the science behind this everyday marvel. When we gaze upward on a clear day, we're not just seeing the vast emptiness of space. We're witnessing a spectacular natural light show, a play of sunlight and atmosphere that paints the sky with its distinctive azure hue. The color of our sky, it turns out, is a result of how sunlight, a blend of every color in the rainbow, interacts with the particles in our atmosphere. But it's not as simple as that. This interaction is an intricate dance, a delicate balance of light, matter, and physics. So to truly grasp why the sky is blue, we first need to understand a little bit about the nature of sunlight. Let's unravel this fascinating celestial mystery together, shall we? But before, like the video and subscribe to MindMingle. Sunlight might appear colorless to us, but it's actually a mix of all the colors of the rainbow. Imagine sunlight as a grand orchestra, with each color representing a different instrument. Red, orange, yellow, green, blue, indigo, and violet. Each color plays its own unique part. Yet each of these colors has a different wavelength, like each instrument has a different sound. Blue, for instance, is like a flute with a shorter wavelength, while red is more akin to a cello with a longer wavelength. When this colorful symphony of sunlight enters our atmosphere, it meets small particles such as air molecules and dust. These particles, much like tiny mirrors, reflect and scatter the light. Blue, with its shorter wavelength, is scattered in all directions more so than the other colors. Now, you might be wondering how this scattering of light results in a blue sky. The blue sky we see is a result of a specific type of scattering called Rayleigh scattering. Now let's think of the sky as a giant billiards table. The sunlight with all its various colors is like a handful of billiard balls being thrown onto the table. The blue and violet balls, small and nimble, bounce around more, colliding with the dust and gas molecules, which are the obstacles on our table. This scattering of blue and violet light in all directions gives the sky its blue hue. But wait, you might say, violet light is scattered even more than blue. Shouldn't the sky be violet? Well, our eyes are more sensitive to blue light and less sensitive to violet light. Also, sunlight reaches us with much less violet light to begin with, so we see the sky as blue, not violet. But what about those stunning sunsets and sunrises we see with their red and orange hues? Sunsets and sunrises are magical times when the sky can take on a whole range of colors, from deep red to orange and pink. This spectacle is due to the sun's position relative to the horizon. As the sun approaches the horizon during these times, sunlight has to traverse a thicker layer of our atmosphere. This longer journey means sunlight encounters more particles, causing the shorter wavelengths, like blue and violet, to scatter even more. They get deflected in different directions, reducing their intensity as they reach our eyes. Meanwhile, the longer wavelengths, like red and orange, are less susceptible to scattering. They continue on their path, undeterred by the particles, and reach our eyes with less deviation. This gives the sky its characteristic red and orange hues during sunrises and sunsets, painting a picture that's nothing short of magical. So, the next time you look up at the sky, you'll know exactly why it's blue or why it can turn a beautiful red or orange during a sunrise or sunset.